So let's solve the one more problem on based on the Laguerre polynomial. Okay, so 0 to infinity e power of minus st ln of t into dt, which is equal to 1 over s into 1 minus 1 over s power n. Okay, so LHS, consider LHS. Zero to infinity e power of minus st ln of t into dt, which is equal to 0 to infinity e power of minus st into ln of t. Write the r is equal to 0 to infinity. Ln of t means minus summation r is equal to 0 to infinity minus 1 whole power r factorial divided by n factorial divided by r factorial whole square n minus r factorial into t power of r into dt. Okay, so summation r is equal to 0 to infinity minus 1 whole power r n factorial divided by r factorial whole square n minus r factorial. Okay, so you have the integration 0 to infinity e power of minus st, you have t power r into dt. So this whole summation r is equal to 0 to infinity minus 1 whole power r n factorial divided by r factorial whole square n minus r factorial is constant. So take it out, the constant outside of the integration. Okay, so now e power of minus st t power of r into dt. Okay, put st is equal to some z. Okay, s into dt is equal to dz. Therefore summation r is equal to 0 to infinity minus 1 whole power r n factorial divided by r factorial whole square n minus r factorial to 0 to infinity e power of minus s minus z by s power r z. R means t means z by s, t means z by s power r. dt means dz divided by s, dz divided by s. So now s is a constant. So summation r is equal to 0 to infinity minus 1 whole power r n factorial divided by r factorial whole square n minus r factorial 1 over s power r plus 1 into, so integration of 0 to infinity e power of minus z power of r dz, which is equal to a gamma function. Into gamma of r plus 1. So we know that the gamma of r plus 1, which is equal to r factorial, which is equal to summation r is equal to 0 to infinity minus 1 whole power r ncr. This whole term will be ncr into r factorial. R factorial into r factorial means r factorial whole square. This whole thing is ncr. Okay, this this r factorial gamma of r plus 1 means r factorial cancel out. So ncr divided by s power r plus 1. Take 1 over s outside of the summation minus 1 whole power r ncr 1 over s power r. Now apply the binomial expansion. Therefore 1 over s 1 minus 1 over s power n. Okay. This whole thing will be equal to 1 minus n 1 minus 1 over s power n. Okay. So the last topic of Laguerre polynomial recurrence relation. We have to find out n plus 1 into ln plus 1, which is equal to 2n plus 1 minus x ln of x minus n into ln minus of x. Okay, we have to find out this thing. N plus 1 into ln of x okay. Consider generating function one over 1 minus t into e power of minus tx divided by 1 minus t into summation n is equal to 0 to infinity t power n ln of x. Now differentiate with respect to 1 over 1 minus t whole square. Differentiate uv. This is consider this is u, this is v. Okay. So next e power of minus x by divided by 1 minus t plus 1 over 1 minus t into e power of minus tx divided by 1 minus t into 1 minus t whole square 1 minus t minus of x. Okay, so which is equal to summation of n is equal to 0 to infinity. So we have to derivate with respect to t on both sides. So n into t power of n minus 1 ln of x. Okay, let's simplify the above expression. So you have a square 1 over 1 minus t whole square. You have 1 over 1 minus t whole square into e power of minus tx divided by 1 minus t. So 1 over 1 minus t into e power of t minus x divided by 1 minus t, which is equal to summation of n is equal to 0 to infinity t power of n ln of x, right? So 1 over 1 minus t into summation n is equal to 0 to infinity t power of n ln of x minus t which is equal to minus 2t 1 minus 2t divided by 1 minus t whole square summation n is equal to 0 to infinity t power of n ln of x. So which is equal to summation n is equal to 0 to infinity n into t power of n minus 1 into ln of x. So if you simplify this, take LCM and bring it to the right side. Okay, take LCM and bring it to the right hand side. Then the expression, you will get this expression. Which is equal to 1 minus 2t plus t square, then summation n is equal to 0 to infinity n into t power of m n minus 1 ln of x. So now compare the coefficients of t power of n. So let's see the summation into 1. Okay, then the summation n is equal to 0 to infinity into ln of x. Okay, don't consider the summation now. Okay, next, so next t into t power n means t power n plus 1, don't consider that one. So next, minus x into ln of x, you have minus x here, and coefficient of t power n, we have to compare the coefficient of t power n. So minus x into 1 into this whole the summation, so that's why I have written minus x into ln of x, so which is equal to, so now, so 1 into this whole summation will we won't get, right? So we have find out the, we got minus x into ln of x, ln of x, so we have to get 2n, and see, you have n minus 1, right? For n plus 1, uh, so n plus 1 into ln plus 1 for this one, for 2n into, so minus n into minus 2n into ln of x, so minus 2 minus 2t minus 2t minus 2t into this whole the summation. So here t power 1 into t power n minus 1, which is equal to t power of n. Okay, you have n here, you have minus 2 here. Okay, next, then t square into t power n minus 1, t square into t power n minus 1, which is equal to t power n plus 1, right? So we need only the t power of n, then keep n is equal to 1, n is equal to n minus n, then you will get t power of n, right? So plus n minus 1 into ln minus 1. Okay, now if you rearrange this, you will get n into n plus 1 into ln plus 1. Okay, which is equal to x into ln of x minus ln of x plus minus 2n into, sorry, plus minus plus into ln of x minus n minus 1 ln minus 1 of x. Therefore n plus 1 into ln of n plus 1 into ln of x, which is equal to 2n minus x plus 1 into ln of x minus n minus 1 into n minus 1 of x. So Okay. Okay. Thank you.